Hey everyone, today I'm going to be looking at general solutions to trig equations. Now, usually when people ask me how to do a general solution to a trig equation, the first thing I tell them is to go and use the calculator. That is the intelligent thing to do, and it is the thing that you should be thinking to do. And I will show you in a later video how to actually do that as well. I'm going to attempt to solve three trig equations here with getting general solutions. It is going to take more than one video, I believe, so let's just see how we go as we get stuck into it. There are some rules that you can use to do these. I actually generally prefer to just find the solutions and then try to look for the pattern in them and go from there. So what I'm going to do is I'm going to solve this equation here. So the angle that x would need to be for the cos function to equal √3 on 2 is going to be just pi on 6. So I can say that x equals pi on 6, and the other solution to this would be 11 pi on 6 in the fourth quadrant. I could write down a couple more even, so we'll go around the circle again. I'd then get 13 pi on 6 and 23 pi on 6, and this pattern continues. Now, what we can see is that these two values here, they're really sort of deviating either side of the 0 degrees or the 2 pi radians or 0 radians. You know, pi on 6 is out there, and 11 pi on 6 is out there. So what I can say then is that the solution, or the general solution, is going to be, well, it's an even multiple of pi, so it's like 0 pi or 2 pi or 4 pi or so on. So I'll just write 2 pi n. The n represents some kind of value, so we can substitute any whole number in here and it will give us a multiple of 2 pi. And then we can just go plus or minus the angle of pi on 6. If I go plus the pi on 6, it takes us to this one here. If I go minus the pi on 6, it would take me back to this one down here. So that is the general solution. There's one more thing that we need to include here, and that is that n is an element of z. Okay, so that z is a bold z. Okay, it's a little bit like the r that we use in real numbers. I should do it again a little bit better. There we are. So it's a little bit like the r in real numbers. You know, that r looks like this. It's got two lines down the side to indicate that it's bold. So just another symbol, and z represents integers, which are all of the whole numbers. Okay, right. So moving on, tan 2x. Now, just so you're aware, having a dilation factor here really does wreak havoc on the general solution. It can be quite difficult to figure out what it's going to be when you've got that kind of thing going on, but you know, we can still look for the pattern and hopefully turn up with something. So I'm going to say that our angle 2x must be equal to, now for tan to equal 1, the angle would need to be pi on 4, so that's one of our solutions. And the other place where it would happen would be in the third quadrant, which would be 5 pi on 4. And I'll write down the solutions if I keep on going around the circle. So we get 9 pi on 4 and also 13 pi on 4. So dividing everything by 2, then that gives x equals pi on 8 and 9 pi on 8 and, oops, I left that one. I'm just going to cross it out. So we had 5 pi on 8, then 9 pi on 8, and 13 pi on 8. So I'm going to draw those in much the same way as I did the last question. Okay, pi on 8 goes out there somewhere. 5 pi on 8, that's a bit more, so that goes up there somewhere. And then 9 pi on 8 would go out here somewhere, and 13 pi on 8 would go down there somewhere.